Welcome you all in our new session that is based on how to draw merchant force circle. Merchant force circle is important to us to know the values of friction force and normal force. Therefore, it is necessary to learn merchant force circle. Before moving to merchant circle, we must know that what is orthogonal cutting and oblique cutting. So for merchant force circle, we are going to prefer orthogonal cutting, that is a two-dimension cutting. When this cutting tool comes in contact with the workpiece, then machining will start and chip will start to flow. But the chips will flow along the rake surface. So here is the rake surface, or we can call it as a rake angle. This angle is designated by the letter alpha. When this cutting tool advances towards the workpiece, then machining will start. So during this uncut chip thickness, or we can call it as a depth of cut, which is given by the letter T or T1, chips will start to flow on the rake surface. The cutting force or horizontal force, this force value and next force, that is thrust force or vertical force, these values of these two forces can be found by using tool dynamometer. Now, after getting the values of cutting force and thrust force, we are going to put it, or we are going to convert it into proper scale and then draw these two lines. Line joining to these two, or we can call it them as resultant. Now it is necessary to draw a resultant for it. So resultant can be drawn like this, and the name given is R. We can draw one circle by considering R as a diameter, or we can find out the center point of the segment R and then we can make one circle. Now this circle is merchant force circle. Thrust force is important because it will hold the cutting tool against a workpiece. Therefore, this thrust force is important one. Now once we draw the circle, then it is the chip thickness, that means the cut chip thickness, we can designate it by the letter TC or T2. Chips will move or along the rake surface. Now by considering this, it means the chips will start to move in shear zone, along the shear zone and along the face of tool. For line joining to the intersection of this T1 and T2 line, which intersects the line T1 and T2, and from the cutting point of the tool, we are going to draw one line which will touch to the circumference of circle. This line is nothing but shear force. Now again we are going to draw one normal to this shear force, and that is normal force. After getting these two forces, next we are going to draw frictional force. This frictional force is designated by the letter F, and it is generated at tool chip interface. Next again we are going to draw one normal line to this frictional force and designated by the letter N, that is again normal force. After getting these lines, next we are going to extend the shear force line, which will make an angle that is nothing but a shear angle. This shear angle is represented by letter phi or beta. Another important angle, that is angle of friction, which is generated here. And this angle of friction is also important to us. In this way, we are going to draw merchant force circle. Now, what are the advantages of this merchant force circle? So the advantages of merchant force circle are, we can find out power consumption using this cutting force and velocity. Then we can find out friction, which is generated at tool chip interface here. Then limitation is, it is valid only for orthogonal cutting. So in this way, we are going to draw merchant force circle in simple way. Thank you.